even and odd identities. Even and odd trig identities. And the best place to start with even and odd identities is the unit circle. So I'm going to draw our unit circle over here. Okay, sorry this is taking me so long, but I'm determined to start making better circles than I used to. Okay, this is pretty good. Now, the unit circle is gonna help us discover some of those identities we call even and odd. You're gonna find out on the next page why we call them so. But let's start right now. So if I take an angle, and this is angle X, right? We found out already that the unit circle is really cool because this hypotenuse over here is equal to 1. And because the hypotenuse is equal to 1, that's why the x and y value of this point on the unit circle are equal to sine and cosine of that angle x. So let's remember, the cosine is the adjacent over 1, so cosine is the x value, cosine of x. And then the sine is the opposite over here, opposite over hypotenuse of 1, and the opposite is a sine of x. Good. Now let's do the same thing. I'm going to take the same angle, however I'm going to go in the negative direction, okay? I'm going to go down in the negative direction, okay? I want to make this pretty, but it ain't working. Sorry I'm taking so long. I'm just learning still how to use this well. This is our 16th video, by the way. So, or actually 17th, because I've done a bunch of other videos before for you. But yeah, I'm learning. So let's say that those two angles are equal. So this angle will be minus x. So if I'm going in the positive direction, I get positive angles. If I'm going counterclockwise, I get positive angles. If I go counterclockwise, right, opposite to the clock, my angles are positive. If I go negative, if I go clockwise, the way the clock moves, my angles become negative. And so this is a negative x angle. It's equal to this angle, but it's negative. And I can do exactly the same over here. I can find the points on the circle the same way, sine and cosine, and I know that what I'm gonna get is here cosine of negative x, and this is gonna be sine of negative x. Now let's notice some things. First of all, those two triangles share one side. It's this side here, which is adjacent to those two angles. Therefore, their x values are really exactly the same, right? Their x values are exactly the same. So this over here is equal to this over here. Let's write it down. This is actually our first identity, first even odd identity. So cosine of x is equal to cosine of negative x. This is our first even odd identity. Here's the next one. Well, these triangles are congruent, right? They're exactly the same. So this side over here is equal to this side over here. Therefore, sine of x really is the same length as sine of minus x. However, one is positive and one is negative. So here's my second identity, sine of x. If it's positive, then this one over here will be negative sine of minus x. Okay, so the first identity is cosine of x is exactly the same of cosine of minus x. They're both positive on this side of the coordinate cis plane. And the second identity is that sine of x going up is really equal in value to sine of minus x. However, it's going to be negative. It's going to be the opposite sign. It's going to have the opposite sign of it. Okay, I'm going to stop this video here and make another one for you to help you fill in the next table you're going to be working on. I think it's easier when we break the videos and make them a little shorter.